LED products are specified to keep a constant color point over their lifetime. And the color point is defined by a couple of different factors. So you have the wavelength of the blue LED, you have the absorption and emission characteristics of the phosphor, the design of the package, and then any optical elements. All of these together need to be designed to remain stable over the full lifetime of the product under all its operating conditions. And when one of them starts to degrade, the color point can start to drift away from its original point, and you get color shift. A human eye is very good at distinguishing variations in color, especially for light sources that are close together. Now, the extent of color shift that is acceptable depends on, on the amount of shift, of course, but then also on the application. So if you look at a street light, for example, a small amount of color shift may be tolerable. However, if you go to museum lighting or retail environments, then basically as soon as color shift is noticeable, it's usually unacceptable. And that means that the product has effectively reached the end of its life. Now, for the manufacturer, the challenge is to design the products so that they are robust over the entire lifetime. That's not easy to do because you want to project a long lifetime, but at the same time you have only a very short time over which you can test the product. What makes it more complicated is that the long-term color shift is something that you cannot easily extrapolate from a short-term test. And that's because there's different mechanisms that can play, and they occur at different color shift rates, and color shift may be in different directions. There's a couple of things that the LED manufacturer can do. On the materials development side, develop more stable phosphor materials, especially for the red phosphors. And then also protection of package materials against corrosive environments. And in general, thermal management inside the LED package is crucial because most of the degradation mechanisms are thermally activated. Also, for the luminaire maker, the manufacturer needs to be aware of the operating boundaries of the LED in terms of drive current and temperature, so that it stays within its operating limits by using proper heat sinks, etc. So that actually you get the performance that the LED was designed for. You get robust performance over a long lifetime.